I'm making the x.com, the everything application one right now. Low level TV teaches 3 idiots assembly. You won't believe trick number 7. Okay. Dude,
hackers hate this one trick.
Hackers hate this one.
Yeah, hackers hate this one trick called not writing things in C anymore.
Dude, but actually though.
Okay, so
Dude,
that's live.
Teej, you were there for the last stand-up, right, with Casey? Yeah, because
Yes.
you brought me onto the dude. The fact that like Intel has all of these control flow integrity mechanisms that Casey was talking about. Casey was like, "Oh, the shadow stack exists," and it's like, "Yeah, dude. The problem is no one gives a shit and no one uses it. So software is just inherently still flawed."
I do like Casey's like, so they probably like, you know, use that thing that stops the problems, right? Oh, right. No, we don't do that here. We don't do that here.
Oh, but the CPU definitely validates the value of a PC before it pops it, right? Nope, it does not, unfortunately.
That is fake and wrong, actually.
Yeah.
I gotta do a little bit of adjusting here and a little bit of adjusting.
Also, well, I don't even know what the shadow stack is, but I'm gonna tell you what. I'm in. I'm like already ready to like pop on some Alex Jones and hear about what it is.
Dude. Let's go.
Okay. Wait. Oh,
I don't see your tweet.
I just sent it. Trash.
Why aren't you tweeting?
I did. I'm trying to do my job. Okay. Here, I turn myself up to here too, so you guys zoop. There we go. We'll go back to here hosting the stand-up. Okay.
Whoa.
Nice.
Hackers hates this one shirt.
All right.
Rust is mid, by the way.
Rusted mid, by the way. I didn't say write it in Rust. I mean, that also solves security problems because you won't ship it, so you're safe.
Honestly, Rust,
It's
not
true.
even low level.
It's true.
Pretty high level.
I use Rust all the time at work, but we use unsafe Rust, so like I regularly get page faults in Rust, which is hilarious. Just kind of defeats the entire purpose of using the language.
Every time that happens, you have to screenshot, put it on Twitter, and be like, "I thought this was safe."
Every day.
Yeah, dude.
Yeah. Okay, I think we're live everywhere, and I hit the record button, so I think we're safe.
Wonderful.
Are we safe?
Chat, hello. How's the volume before we get too far?
Hey, chat.
How's the
Hi, chat.
volume?
Hello, chat.
Hi, chat. Look at chat. I got Magic the Gathering cards 5 seconds ago, so if now I show them on screen, I can expense them.
Oh my goodness.
The IRS has entered the chat.
Vegan, should I tweet it right now then? The tweet I've been meaning to?
Which one? Oh, yeah, tweet it.
Not expensing Magic cards is literally discrimination against autistic employees.
It's
Oh my
true.
goodness.
It's true. Also, they're called therapy objects. All right, like if you open them, they're.
Oh, what? You guys hate people that aren't like you? Okay, interesting.
Real quick, Teej, why am I 144p? Why is it only
I know,
me?
you-
Why
Yeah,
is
what
it
is this?
me?
It doesn't matter. I don't know how many times we have to go over this. At this point, I'm confident chat knows. They've seen the stand up on
he does
YouTube. It's everybody has high quality recordings.
Can I be honest? There's a setting where he goes there and he goes, make Vegan look 140p. And then it upsets me and he's like, it's okay, it'll be fine in post. Okay, sorry.
That's exactly what happened. Great story.
Stand up
Vegan.
time.
Great story, Vegan. Vegan, any other stories? Quick, we can put it as the intro to this episode.
Yeah, sure. Big Z's not happy, but we were just in line at the Magic the Gathering store, surrounded by a bunch of Magic and Pokemon nerds. And we were talking about the Final Fantasy set, and my girlfriend asked a group of nerds, Final Fantasy. Oh, it's like the basketball thing? And no one laughed.
What, like fantasy basketball?
Yeah, no
We
one
don't
laughed.
know. We don't know.
They just looked at her and they were like, how does she not know? We had to get out of there fast. So
You start
You just
throwing
hear someone
food
racking
and
a
bricks.
shotgun like. Oh,
we don't like your tap around here. This is for nerds.
No, they were all just still shell shocked about someone going in there that had a girlfriend.
Yeah, no, I was flexing on them.
You put your arm around her.
Yeah, no big.
This
She
one's
was like
mine.
not in public.
This one is mine. Oh my goodness.
Why is my scene better than Prime's? Because I'm just sharing the page from Riverside. Unlike Prime making 45 different scenes to just show this.
I've always wondered that. I was like, can you just stream the page? Like, it's already like in a decent format. But, yeah, you know.
Teaches us assembly. All right.
Boom.
Okay,
Ass,
I think
teaching us
easy
ass
cash
everything?
money.
Yeah. That's how you abbreviate it, or what? What's the abbreviation for assembly?
Yeah,
ASM, baby.
ASM.
ASM.
Oh, it was
I wish
close.
it
Assembly.
it
It was
should-
close,
it should be
trash.
ass. This should have been.
It should be ass. That's crazy.
Yeah. I can't see Post Malone in the bottom right. YouTube chat got him.
Oh my god, that is so. Okay, that's the intro right there.
That's the intro.
I hate this intro.
I hate this. Okay, all right, I'll do an intro and then we'll get started for real. Watch this, guys.
Is this
watch
our
and
first
learn.
No Prime stand-up?
Watch and learn.
Okay?
This is how it goes. Ready for this?
We fired Prime finally.
All right. Hey guys, stop. If you're expecting a regular episode of the stand-up, it's not going to happen today. You might actually learn something. So that's why we've got Ed here. We kicked out Prime and we kicked out Casey. Why'd we kick out Casey? Because he already knows this and he'll make it look like idiots. But that's why we've got me. We've got Trash. We've got not TJ. And then we have Low Level. Formerly Low Level TV, now just Low Level. And he's going to tell us about assembly and teach us. So that's where we're at today, and we're going to have a good time.
Let's do it up. Hey everybody, yeah. So Low Level here. How you doing? My day job, I am an offensive
Do it like a
security
YouTube
researcher.
intro. It's not quite crazy enough, Ed.
What's that?
Hi.
Scream.
More YouTube intro, less like we're hanging out as
Hey
friends.
guys, what is up? If you're new here, smash that sub button today. No, I'm not doing that. Right. Today we're talking about assembly, guys. Here's the thing, right? For two reasons, I think it is very important that every developer knows about assembly, right? Here's why. First of all, I am a security guy. I personally believe that you cannot secure systems that you do not understand. Therefore, learning assembly is kind of like, it's required, okay?
Wait, Ed, I have a
Second.
question about that.
Yes.
Is
Denise,
that
yes.
why the one guy couldn't secure T because he didn't understand women?
There are multiple layers to that ogre that we're not going to go into, but I'm sure that was one of them. That,
Okay.
that may have had something to do with it. Yeah, man. So, God, the T app is crazy. Okay, anyway. And then number two, there is a fundamental fear that I have that the Linus Torvalds of the world, the people that kind of literally architected CPUs as we know them today, they're all gonna die. Like, let's be real, eventually. And we kind of need, I think, to usher in like the next generation of those people. And I think by, creating a culture of learning lower level stuff, hence that's my name, that's the name of the channel and me IRL, it kind of, I think, ensures we have a more secure world, right? Because if we have a generation of people that use computers but don't know how they work, it's kind of a scary place to live, in my opinion. So the game plan today is we're going to talk about computers, talk about assembly, and it's going to be a good time. First, I'm going to show you Riverside. That was the plan for that. No, it wasn't. So if you guys do want to follow along, I'm talking to chat right now. The link is in the chat. You guys can go ahead and go clone that.
We'll
do
put
a
it
little
in
bit
the
of assembly.
description of the YouTube video too.
And it'll be in the description below.
Yep.
Smash that like button again.
This is
Right,
interactive
on your way
stand-up.
there. On
Yeah,
your way
right.
there. It's free.
So to kind of set the stage here, okay, we're gonna do. Oh, am I mirrored? Does this look right? Can you guys read this?
No, it's perfect. It's perfect.
It's
on our
perfect.
side.
That's good. That's good.
Looks really good.
I'm going to begin to describe computers in a very oversimplified fashion, okay? Casey Moratori in previous stand-ups have talked about this thing called the back end and the front end of a CPU. The front end of a CPU is like the interface that is meant to lull you into a false sense of security that things are simple, right? So I'm speaking about computers from the front end perspective, okay? At the end of the day, all a CPU can really do is do math and touch I/O and read memory. So it's do math, read memory, touch I/O. The main way that it does this is through a couple of very simple components, right? You have these things called registers on the inside of the CPU, which are basically, think of it as like hyper fast named memory, right? You have these variables that live in the CPU, they're extremely quick. And then with those variables, you either do memory operations, so you store and load from memory, or you do math on that memory. That's literally all programs do for the most part, right? There is some I/O the kernel has to do, right? To touch a mouse, to touch a keyboard, touch a screen, but everything else is like extremely simple. This model here is known as the von Neumann architecture. I'm not going to go too deep into this, but basically you have these buses that allow the different components we talked about here. So the ALU that does the math and the registers to talk to each other, right? You have this control bus that kind of says like what the state of the CPU is. You have this address bus that says, hey, what is the location we're doing things? And then this data bus that says, what are we doing there, right? So that's not super important for the actual
Vegan?
assembly lesson today. But this, like, I think it's important to simplify the computing model because as you're learning it, if this stuff feels super scary and like like arcane and like black magic-y. It's really not. It's really, really simple, right? All the CPU can do is move stuff around and then ask a higher privileged part of the computer to do I/O. That's it, right? So that's kind of like the design part. We'll get into the coding here in a second. Any questions from the class while we're
I have 100 questions.
Yes. Okay. What's up? Send it.
So Von Neumann, first of all, it's the tube guy. I've been buying tubes from a guy named Von Neumann. Is that the same guy?
That sounds correct.
Yeah,
No,
okay,
no.
cool.
I thought it was the guy. He kind of does interviews and stuff like Theo von Neumann.
Theo
I thought,
Von.
That
Theo
sounds
Von
more
Neumann.
correct. He had
Okay.
Sam Altman on recently. Von
Yeah,
Neumann. Yeah. Perfect.
Oh,
Did he
okay.
actually? Oh.
Yes. Remember, if you want to look like a human, you go on Theo von Neumann and you try and say, "I swear to God, I'm a." Real
that's why
normal
they call it
human."
the Turing test.
I drive a Cornish egg because I hate money, guys. That's how it
guys.
works.
Yeah.
I'm a normal guy.
It's just for the love of the game, boys.
It's for the love of the game, baby.
Okay, actual serious question.
Yeah,
'cause
what's up?
You had the word bus 3 times and different words next to it.
Yeah.
Now I've ridden on a school bus.
Okay.
I
So he
know
has
what that is.
experience.
Yeah,
Yes.
on the short bus.
Now I've worked at a couple
Long one,
companies.
short one.
Well, it was like average size bus. It was like
Okay.
a normal size.
Statistically average bus size.
Statistically
Okay, got
average
it.
bus. And then I've worked at some enterprise companies where we had an event bus, and there was a guy with some very nice pleated slacks
Okay.
that was always talking to us about the event bus. What does bus mean here?
Yeah, I mean, a bus is just, you could think of it as a shared place to put information where there are rules about who's responsible for removing and touching that data and like in what order, right? There's a lot of like internal stuff about like electrically like who blocks different buses and like applies impedance to buses and stuff, but generally it's just like think of it as a place to put information. An event bus, right? You broadcast an event and then people can remove that event from some kind of like queue, right, or some kind of list. And
So it's like
the
you have
address
like
bus,
like a bus of children.
yes,
And then the rules are you're only allowed to take children off if we're at their stop.
right. Ideally.
Okay, cool.
Yeah, a couple school bus drivers in the South that I know of, maybe not have abided by that rule. That's okay. Well, the kids were all right. It's fine. So anyway, let's go into
Seatbelt's
the coding
optional.
here.
That's all I know so far.
What's that?
Seatbelt's optional. Security.
Seatbelt's optional,
Security's a suggestion on the bus. That's what I know.
Security is a suggestion on the bus. Okay, so the way we're gonna do this, Teej, if you wouldn't mind pulling the screen over to you and then going
Yeah.
into the repo that I have, we're gonna kind of cat the README to talk about like generally how this is gonna go. Yeah, if you want to
I gotta fix myself. Here we go.
MD,
Okay, there we go.
Let's do it.
glorious.
honest,
Okay. So we kind of talked about what computers are. I'm messing up my order here a little bit.
I'm backwards.
Uh-oh.
I'm backwards
It's
on the.
backwards.
I'm backwards on the stream. I don't know
Oh,
how to
God.
not mirror my own
guys,
video
it's okay.
in Riverside.
He doesn't want to get hacked. This is good. This is good, guys.
Chat,
This
how
is
do
how
I
you prevent getting hacked?
It's obfuscated. This is obfuscation.
studio info? Chat. Audio
Oh, guys,
video.
this is Japanese code. You have to read it the other way.
Mirror video. We got it,
The
boys. There we go.
programming in manga.
Yeah.
Okay. It's only because I'm looking at my version of the screen, all right? Relax. This still is better than Prime's, okay?
It is.
So-
It is. It's true.
Okay, okay.
Okay, so we're good now, right?
Yeah,
Okay,
we're good.
perfect.
We got it.
So we talked about what computers are, right? Assembly, the language today, all assembly is the Englishification or like the humanization through these things called opcodes, which are like instructions that describe what the computer is doing. Now, by the end of this lesson, what we're going to do is take a program that has been compiled from C down to assembly and reverse engineer the functionality and extract a secret flag from that program, okay? Because what we're able to do by reading assembly is like, when you compile programs from source down to assembly, there is inherent information loss because you lose the names of variables, the names of labels, all these things that the human needs to understand and contextualize the code goes away. By reading the assembly, we get a ground truth representation of what the CPU has to be doing, and therefore can reverse engineer, can recontextualize that based on the reality of what the code does, right? So we'll use that assembly to kind of figure out, hey, the crack me is doing this. What does that imply about what the program is required to do, right?
All right, two things.
So,
Two
yes.
things from my side. Number one, reverse engineering. That's what I like to call working with Began, because it seems like everything goes backwards. But secondly, Ed,
Mordorio can confirm that.
can you switch back to your cam on full screen view?
Sorry.
Because you're showing your screen. There we go.
Yes.
Perfect. Okay.
Got it.
Wait, so this is I just learned something. So assembly doesn't need variable names. So variable names, they're just comments for humans.
Yes.
computers don't even eat them. I assume like they fed on them or something. But.
Yeah. No, we'll see in the reverse engineering, a variable name gets boiled down to an offset on the stack, which is pretty neat.
So next time someone says rename this variable, I'm gonna say actually all variable names are just for humans.
Can you change the offset for me?
The computer doesn't care, actually.
I don't like that offset. Change it.
Love that.
I'm literally gonna say that in my next.
Knit,
my next, like,
bad
stand-up.
offset.
Bad offset. I'm more of a hex 10 kind of guy, actually.
I'm totally saying these to my coworkers. They're like,
Oh
what
my
are you
God.
talking about?
Relax,
It's
bro.
crazy.
It's just a mnemonic.
It's just a mnemonic. It doesn't matter. All right, that's crazy. Okay,
I'm actually learning. This is great.
great, sweet. All right, let's keep going then. So what we can do is move into the move folder. So the order of operations here kind of describes like what operations we're going to teach and in what order. The way we're going to do this is, I think, step one, Teej, can you actually go into this folder? I want to get you familiarized with your debugging setup. So
Okay.
if you can just like CD into that folder real quick.
Okay.
CD move and run a little make. I'm assuming you're in the image right now.
Boom.
Perfect. Okay. And what we're going to do is run GDB on this program. So I think, yeah, we're going to GDB.
Oh,
yeah, it's going to
man.
be crazy.
We should
And
have done this on
immediately
Windows.
after
We
we
could
had
have
the
rad.
stand up where Casey said he hated GDB. So we're going to have, it's going to be interesting. We're
We
gonna
could have done this
fun.
with
Casey
rad
hated GDB, I hate
debugger.
it too.
We should actually use rad at some point. I need to use rad personally. I've never used it. Okay. Hit Q to get out of this little menu here.
Okay.
And then wait, quit the program. Okay. Don't do it
Remember,
again?
Teej doesn't
I'm
know
here
him
now.
that well, so you got to go slow for him.
It's true.
I did exactly what he said, Vegan.
Let's do lay next. What this is gonna do is change the layout of GDB, right? So
Lay
it's gonna make
next.
it
Say-
like lay space next, literally in that.
Like this.
Yes.
Okay.
And hit enter again.
Whoa.
Yeah, we're out here hacking, guys. One more time.
Whoa.
Yeah, dude.
Okay.
This is where the hacker man's come out.
Okay.
Okay. One
This is
more
a
lay next.
far away from the Chrome debugger.
This is like level 10 of that Shenson game. We're killing it.
One more time, Teach. Hit enter.
Wow.
Okay,
Okay.
great.
This looks
So
like the game. Okay.
one more
sorry.
time. Sorry, I forget which one it is.
Okay. One more time. Right here.
Yes, good, perfect. Assembly register.
Okay,
Okay.
nice.
So
Close
when
one.
you're learning assembly, I feel like the easiest way to learn it is to like kind of get into the flow of like, okay, we know what the CPU is doing, because we can literally step by step run through these instructions and see what's going on. Okay. So to do that, we set these things called breakpoints, which we've talked about in previous stand-ups, right? But a breakpoint is basically we're telling the CPU, hey, when you get to this location, do me a favor, stop execution and let me see what the heck is happening. The way we set up a breakpoint in GDB is we type B for breakpoint, and then just B space, and then underscore start, which is the label we're going to break at. Hit enter. Yes, hit yes, it's fine. And then hit R for run.
Wait a minute. I watched your video last night, and you said R stands for really big.
Hold on.
Pause.
Do R space. Okay, fuck. We didn't. Okay.
We didn't
Back-
make
back-
anything yet. I need
No,
to.
the program. You compiled it. Do R and then / program. God damn it. Hit Control D real quick. Okay. Yeah, do GDB / program. Sorry.
I was just waiting for it to go.
Wait,
Okay,
wait.
press enter, and I have access to your computer. Teej, you idiot.
There we go.
GDB.
GDB /
And report now.
just GDB / program.
Gotcha.
Perfect. Now do what we said before. So lay next. a few
Lay
times, so you get
next.
assembly
Enter.
in-
Right here.
Good. Perfect. Yeah.
I'm getting fast, Vegan.
sorry,
I'm gonna
breaks.
kill your splits on the speed run
Okay,
for this
please,
one.
please do
We're
not
gonna do
attack me.
a speed run later for sure. B _ start for break start, and then do R. Glorious. Perfect. There we go. Okay.
Whoa.
So here's where we're at, right? We
Can
have
your
broken-
JavaScript do this?
Yeah, I know. Can your JavaScript overlords do this? Can your OCaml do this, Teej? I don't
Yes.
know. I don't know. It can. Okay. I know nothing about OCaml.
Because it's
Oh,
compiled.
okay, never mind.
It's compiled,
Okay,
so
my
we
bad, my
can
bad,
do
my bad.
this part. We can debug with GDB.
So what we're looking at here, guys, is the assembly instructions of a program that will tell us what is going to happen in the program, right? So we have these move instructions that is currently in AT&T syntax. We're not going to actually write this, but basically what we're seeing
AT&T
here.
syntax. Say that again.
Sorry,
What-
so
what
there
is
are
happening?
two syntaxes
Okay.
in assembly. One of them is AT&T and the other is Intel. If you think about how variables are assigned, right? Like int x = 0 in C, the assignment from right to left is what's known as Intel assembly, like Intel syntax.
Okay.
And I find that much easier to read than what you're currently seeing, which is what GDB defaults to, which is AT&T syntax.
Okay.
The AT&T syntax is a left to right assignment. So this instruction here says move the literal 1 into the EAX register, okay? We talked about registers previously in that little kind of design setup. A register, again, is just a named variable inside the CPU that has a particular end state or a particular purpose. And we'll get into the purpose of those in the functions area. So this is how you set up a GDB hook. This is how you set a breakpoint in code that you've written. So we can get out of here, Teej, with the Control D again, and we're gonna actually write some assembly now. We're gonna write a little bit of code in assembly to kind of prove that we can change the program and make it do things.
Okay.
So if whatever text editor you want, I'm assuming I know which one you're gonna choose. Yep. So we can let's do a new move instruction, right? So the way we do that is we can just type a move instruction in the start label. For those of you that may be curious what we're looking at here, this is kind of the boilerplate code that tells the assembler how to set up the program. This all is not using libc. This is using what is called just a raw elf, effectively. Elf being the executable linkable format.
Call me elf one more time. That's all I know.
And call me elf one more. You're a little elf. It is a little elf, actually. You know, this guy should get punted by a Will Ferrell or vice versa. So what we're doing here is we say, hey, we create this start symbol. The start symbol is a symbol that the linker and the loader look for to make like the entry point for a binary. We put it into the text segment of the program, which basically says, hey, this is executable code. And then when we're writing the code, we want to use Intel syntax with no prefixes because it's just easier to understand for human beings. So then, Teej, yeah, we can do, let's do move EAX4. Right, let's just do that.
Does that underscore have any significance?
Bro, it was just writing shellcode for you, by the way.
Dude, execute all that. That was good. Teach.
Whatever that
just
compiled
let to complete the rest. Okay,
Teach,
here we go. Here we go.
Tab.
Here we go.
What is it doing here? Okay,
Let it do it. Let it do it. It's good.
It was writing some kind of syscalls. I don't know what syscalls it was doing.
It was just
kind of
real quick. Someone's
I have a
been
question.
poisoning.
Yes.
Dude,
Does
go
the
ahead.
underscore for start have any significance here?
Oh god, I think underscores imply that it's an internal label, so it's like you're not supposed to overwrite this technically, because like
I see.
like when you're actually coding in C, the start label is used by libc to run libc start main that calls main. So I think because it's underscored, it shouldn't be touched. I'm not sure about that completely, but I think that's it.
Ed, do you think that the AI is trying to bootstrap itself into taking over my computer? That's what the suggestions were. What are the odds of that?
Dude, the odds are high given that like I've written and looked at like reverse shell code, and it looked like that. It's a bunch of like very small snippets of assembly that do syscalls that make a socket call or like a TCP call out to someone's computer. So you may have almost gotten hacked, dude.
I knew it. I knew this stream is gonna end with me looking like an idiot and Ed in control of my computer.
Yeah, just getting. Well, I mean, at the end of this stream, we are gonna run a program that I compiled, and he doesn't have source on his computer. So we'll see. Maybe. I don't know.
I love that. I love that. Well, that's like an everyday kind of thing. Ed just sends me random executables to test out for him.
Hey, Teej,
it's not malware, I promise.
It's for Mordoria, I swear.
Just test it out and make sure your computer's fine.
Yeah, exactly. Okay.
Nice.
So yeah, let's go ahead and compile this real quick and just kind of prove that hey, we control the code, right? We're in charge, not the computer, aside from compiling the one to insert that shellcode. So if you get out of here, run
Look at
make.
that. I can just run make. I can just run make from here.
From the command line? That's crazy. Okay. Yeah. And then let's go to GDB and just be like, hey, cool, we're stepping through and we see that
Wait, why didn't you do any pi? You said no pi. Why?
We can go into that if you want to.
Well, it just doesn't seem like I wouldn't add a no pi option to anything I run.
Man, look at Teej. Teej is just flying
Teej,
through this. What?
Dude, Teej is secretly a reverse engineer,
sandbagged.
man. He's out here to hustle me, dude. I swear.
He definitely sandbagged us.
All right, cool. So we want to kind of prove that we control the code here and things are actually happening. So we can run the step
I see our 4 right here.
Or the step I command in GDB.
Step I like this?
Sorry, single word.
Okay.
Yep.
1. Or just step I.
So this will run a single instruction in assembly, hit enter. And we will see that the program counter now proceeds to the next instruction, and the number 4 has been set into RIX, which is a 64-bit version of EAX. Just for you guys to know, the context of this tutorial session will be 32-bit assembly. GDB thinks we're still in 64-bit mode. I'm not really sure why, but RIX, for all intents and purposes, is EAX. Cool. All right, so we've proven to Teej that we control the code. The thing
so
that
that's
I think people
you're saying right up here. This
yes.
We're saying, hey, we put this number right inside of here. That's what we just did with the first instruction. So now this is a register AX or something, and it's here. We're happy.
Yeah, so the way that registers work in Intel is the naming has come out of kind of the growth of the size of the instruction set. So originally it was AX, the extended A register, which comprised of AH and AL, A high and A low. So they're both single bytes, 8 bits. AX is the 16-bit lower half of EAX, which is the 32-bit a register, right? And that applies to all of the X's, BX, DX, CX. You have SI, which is the string copy source value. And if you're doing a string copy, there's a destination. That's RDI, the destination value. And then BP and SP are your stack variables. So basically you have the bottom of a stack, which is the base pointer, and the top of the stack, the more negative value, which is the SP, the stack pointer.
Wait, where does Charlie XEX fit in here?
I don't
I'm sorry,
know who
I'm
that
so
is.
stupid. You don't know Charlie XEX is? Okay.
Dude, like, name any cultural phenomenon. I haven't seen it.
Chat,
I
that was
don't
a
know what it
great
is.
joke.
That is actually a
Zero.
banger, Beacon. We're putting
That
that
was
in
a
a
banger.
short.
Okay,
We're
I
putting
have
that in a
literally no
short.
idea what he's talking about.
You didn't celebrate Brat Summer? Okay, I'm out. Let's go.
Yeah, that's crazy. Oh, Brad
What-
Summer.
what is-
Okay,
what
wait, I
is-
know
what
Brad
is-
Summer.
Brad
What is-
Summer's from Charlie XCX's album. Thank you,
Oh
someone
wait, no,
loves
wasn't it? What is it? Sabrina Carpenter? No, the other one. What's her fucking name? The lady with the.
There's
the Brad
more
song?
than 2 girl singers, guys.
Well, okay.
Name
okay.
100 women right now.
Not
Ben.
Sabrina Carpenter, the other one.
Oh yeah, you like women? Name 100 women. All right. Anyway, cool. So, as we're doing assembly, it gets kind of boring pretty quick, right? Because like all we're doing is like moving shit in and out of registers, right? Like who cares? I guess like what matters. Contextually, it's important to understand that when we're writing code on Teej's computer remotely from my house, we are writing code in the context of a user mode process, which means it is unprivileged and it literally can't do anything, right? It's very stupid. It can't make any changes to the CPU. So we have to ask a higher privileged entity, God, if you will, to do things on our behalf, right? This is called a system call, and this is where things actually get more interesting. So Teej, if you would not mind Googling 32-bit syscall table for me.
32
And it should be like a Chromium
syscall table. What did you say?
we call it teaching now, but yeah.
the
that doc
Linux.
right there.
This one work okay?
Yep, perfect. And then make sure you're on the 32-bit version for, yep, that one. Cool.
Right here.
Okay, so operating systems, their job is to expose an API or an ABI, an application binary interface that allows a user to do certain things to the system, right? And so in Linux, 32-bit mode, this is the ABI table, the syscall table to do things to the Linux OS. I think it's so important that developers understand at the end of the day, all of your code ever is doing is moving stuff in and out of registers and making these syscalls. That is all your code ever does ever. I don't know what the nice syscall does.
Nice.
Well, I was
I
just
really could
scrolling
not
through
tell.
because I saw fork and I was looking for like spoon and knife but I don't really know where else I'm supposed to find stuff here.
Yeah.
Do
So
you have this whole table memorized? I'm just curious.
absolutely not. I know, like, you should know what you're looking at, like, what even is this? But if I told you, oh yeah, obviously the right syscall is syscall 2, where EBX gets the pointer to the FD, like, no, dude, that's crazy.
Trash, you're telling me you don't have all... sorry, let me go down. I'm still scrolling on the same table. Because you don't have all 383 memorized? And you think you can write TypeScript?
Oh, that's a tweet. That's a tweet.
That's a tweet. You're a systems programmer.
Name all
the
384,
syscalls.
whatever these are called.
Whatever these are called.
We don't even know what they're called. We're a little behind.
We're a little behind. So, Teej, you would mind going to the top of this table here?
Yeah.
You got, like, index 300.
Wait a minute,
to the
that
very
last
top.
one's
Yeah,
unknown.
give me
There's
5
question marks across
minutes
the
to get
board.
back to the top here.
Yeah,
Okay,
so
there we go.
right there.
we go.
Okay, I want to show you the arguments to this, right?
Yes.
So the ABI is an interface, right? Interfaces describe where you put data before other people do things, right? So the way that we make syscalls in Intel Assembly 32-bit mode is we set the number of the syscall we want to do. So for example, exit is syscall 1.
Right.
And then we set the other arguments amongst the other variables, right? So when you return out of a program, you want to tell the OS what happened, you put the error code for that exit status in EBX.
That's exit
So-
0 or exit 1, for example, to say whether something was good or not, right?
Exactly, and it happens right there. So Teej, I want you to change the program we were just working on to make it exit 1.
Ooh, okay, all right. I'll give him my best go. Can I put that here in start still, or do I need to put it at exit?
Well, you can tell me, because if
Ooh,
we exit,
I think for syscalls, it'll stop the execution of the program anywhere I want. So I'm
Yes.
gonna guess for this one, for exit, I can put it anywhere I would like.
exactly. Yep.
Okay.
I don't like how quickly Teej is understanding all of this.
So guys, also, I want to make
I
something
don't
very clear.
appreciate this.
I am highly caffeinated, and I am from New Jersey, so I will speak very quickly. If you have questions, please stop me. I will happily answer them. Chat included too. I'm not really reading chat right now.
I
but
just
if you
think
guys-
that Teej definitely planned ahead of this and is pretending. I don't know anything about assembly. Oh, it all just makes obvious sense. This
He
is
just
Teej-
like
This is a
or-
setup. This has been a setup the
Vegan.
whole time.
Or I've been listening to Ed instead of trying to think of random pop culture references to make that no
don't-
one else would understand.
I don't have to think of them. They pop into my head
Yeah,
automatically.
exactly. Teej pre-read the article for sure. No,
Pre-read the pre-read.
pre-read.
Okay, so I missed this part though. So how do I make? I don't know how I say the syscall. Like, do I do move EAX? Is that what you're saying? Which is the one?
Sorry,
where
I did miss one fundamental thing. So what we do is we set up the syscall by putting values into registers.
Right.
And then we have to tell the syscall to occur, which is that int 80 down there. That instruction is an interrupt 80 that tells the CPU, hey, go run the syscall interrupt in the current or in the OS.
Right.
So we do.
So that's interrupt 0-1. That's right here.
No, sorry. So the syscall number goes into where? Based on that table.
Oh, I see. I don't know. EAX. I got to move EAX to 1 here. Or I can write it like this so that it looks the same.
Yep.
Then this you're saying is 80 always.
Yes.
Right? And then I need to put something into the base argument so that I can say, Began wrote, or if this was here, I'll be prime, guys, for a sec. Wait. So, sorry,
I'm trying to watch Teej's screen on Riverside, but it's like 180p, and I can't see anything.
Oh, wait, really? I see him crystal clear.
I'm watching on Twitch. It's great.
But there's a delay on Twitch.
Yeah, but it's close enough. It's close enough. So I need to go move EBX, and then if this was prime, he'd go. Well, he probably wouldn't write 0x69 because he'd be like, "Oh, that's not actually 69." Instead, he'd go what, like 45?
Hex 45. Is that 69? Hold on. Did you just know that off the top of your head?
Pretty sure.
Wait, what?
No shot. He's correct. Yep, that's 69. That's crazy.
Okay.
Teej is like a teacher's pet. Teej is like a teacher's pet.
Guys, it's just 4 times 16 plus whatever the number is. So do 69 minus 4 times 16.
Pre-read.
Nope.
Pre-read.
I don't like
didn't
you
need
anymore.
to study.
I don't like you anymore.
I
Get
did
him out of
study,
the class.
guys. 10
Get
years
this
ago
guy
when
out
I
of here.
went to college. Okay?
Oh, I went to college.
Look at me. I have a degree.
This is study shaming.
All right, so let's.
I save this. I run
save
make.
it, and then make it, and then you can get out of here. It's screw GDB. We don't even care about this anymore, right?
Ooh, right, because I can just go program.
Yep. And then echo $? Question mark. Bada bing, bada boom. Nice, baby. Nice. So, guys, what did he do, right? He wrote a program in assembly that made the exit system call to the OS, which told the OS to kill the process with an exit code. What exit code? The value in EBX, hex 45, decimal 69, baby. That's it. Bada bing, bada boom. Cool. Who's confused? Anybody? Any questions from the class?
I don't understand anything still.
Okay. What questions do you have?
What is assembly?
Oh, Jesus Christ. What is a computer? Okay, someone in chat asked why int 80. So to make a syscall occur, it takes a specific instruction that you need to tell the CPU to take an action. In 32-bit assembly, it is int 80. And in 64-bit assembly, it is literally the instruction syscall, right? It's just a different instruction based on the architecture. And in like in ARM, it's like service 0 or something. But basically, the int is telling the CPU, hey, we have set up a syscall. Go look at the register state to tell you what to do. And then the OS takes that action. Yeah, exactly. Teej knows. So you can do strace. And what strace is going to do, it's called system trace. It's going to look at every system call the program makes during execution. You will see here there's only 2 syscalls made. The shell is exec-VEing our program, meaning it literally just takes our program and loads it. And then the only other system call remaining is the exit system call with the parameter 69, right? And how do we set that up? With the registers in that program.
So all system calls you have to set up properly in a register. Then you say, hey, dog, set up that system call for you. You know where it's at. Go look over here. And sometimes they need extra variables. Sometimes they don't need extra variables. We can tell if they need extra variables or not because there's this chart right here. arg1, arg2, arg3, arg4. What is the maximum number of args anything takes?
Oh, God.
5, 6 right here.
Yeah.
0,
well,
1, 2, 3, 4, 5.
So we could make a new architecture that takes 7, and then we're rich, right? I'm trying to make money, guys.
You could do that. That's 100% true. That's big money plays right there, baby.
Smart.
Big money plays. Okay.
There are variable argument functions like printf, for example, that after a certain number look on the stack. So it's like fast call using registers until a certain point, and then like it'll look on the stack for the rest of them. But
there's a print one.
No, so I'm thinking of functions that take variable arguments, like in libc, for example.
Gotcha.
Like, but I think the syscall interface is always a hardened like n number of max arguments.
Yeah. So
cool. Okay.
I think and the other thing to mention here is like you should just think about this line. I feel like looking like a function. Here's the name of the function, right? And then here's the list of arguments that you can do. So it's just like, okay, we have an int error code. So it's like, okay, there's exit, and then we got to load the first thing into that argument. How do we do that? We set kind of like almost, you could almost think of like keyword argument, right? I'm going to set EBX to be this number. I'm going to move this number into this, or I'm going to move this number into this value, right? So it's like,
exactly.
This is kind of like, is this a comment in this language?
I think it's double slash, yeah.
Okay. Right, this is like the same thing as like basically EBX equals 0x45, right?
Yes.
That's how I should think about this. So then this is just saying, yo, you're going to call, now we're going to do this function, which is exit, with whatever EBX was, right?
Exactly. Yeah.
And then if it took more arguments, then it would load more of them in.
Okay. No, that's completely correct. That's the right way to think about it.
Okay, nice.
The reason we use the exit syscall to start is because there are no pointers involved with exit. It's like it takes a literal int and like you and the syscall number, and that's it. It gets a little more complicated when you do like writes and stuff. We can get to that in a second.
Yeah.
Any other questions from Trash or not TJ?
Okay, I know I'm very stupid. This is like maybe dumb. Like, so obviously I'm trying to make money here. So obviously we want to we can make the fastest programs possible with assembly, right? I know that. Roller Coaster Tycoon, FFmpeg, the 2 greatest programs of all time.
True.
Could we do like, because I use this is even library a lot in my code. What would that look like here? Like, so that's like the simplest thing ever, right? You're saying is even. Is that something that you could break down like right now and show us? Is that hard or not?
Ooh, I'm trying to think.
Because that might help me. Because then it's like I get confused because it's like add a number, move a number. I'm like, okay, I only know how to add and move numbers. I don't know.
So how about this? How about this? When we get to the function lesson, we can write is even in assembly.
Okay, thank you. Thank you.
Okay.
Vegan. And then we can, with FFI, publish that to NPM.
Ooh.
And then we can have the fastest is even library out there.
We're gonna be so rich here.
So rich. Can we try is odd, guys?
Yes,
we can try is odd too.
I just realized I was muted this whole freaking time.
That's crazy.
And I was like, literally no one is listening to me. I was like, this is BS. Could I have, for the EAX and EBX, could I just use EAX for all those?
Okay. So let's look at this from the perspective of the operating system, right? When the operating system gets instructed to do an action, how does it know what actions to take?
The syscall thingy.
The syscall tells it to take an action.
Right.
But how does it know what to do and how to do it? Right? It has to look in the place designated by the interface.
Okay.
So if you set them both to EAX, what you'd be doing is setting the syscall number to 45 or 69, and you'd be calling whatever that is. If you wouldn't mind scrolling down to the 69th syscall. So you'd be telling the operating system, hey, I want to do an S set mask syscall, which is incorrect, right? You want to do an exit. So it depends on EAX having the actual syscall number, which is 1, and then EBX having the value. Again, this is just like I'm trying to think of like an interface example in.
I feel like it's kind of like if you were in if we were in JavaScript land, Trash, because I know you know this one. Like let key equals, and then we're gonna call this one exit, right? And then we go like let arg1 equals 0x45, which we can do in JavaScript, right? And then the table is kind of like let values, right? And we have kind of like exit, and then it's some function, and it takes arg1, and it does something, right? And then we have other stuff here. We have other values. Fork. And fork takes no arguments, so just like this, right? And then we've got read. Ooh, that one takes 3. arg1, arg2, arg3.
Teej, I don't know JavaScript, but this is actually helping me immensely.
Good. I'm happy to hear that. That's awesome.
Right. So then we're gonna every time we say do the syscall, it says values key, and then passes the args.
Right.
Like this, basically, right? Kind of like this. I think this is at least resembling JavaScript. I don't know if this works or not.
That's fine. This is fine.
Right. So then it says, okay, so we can't use strings because that's cheating. Strings don't exist yet. So instead we just say, yo, exit's actually 0, 1. Right. So instead,
it's like an enum. Yeah.
It'd be more like this. It's a list, right? And then this one is exit. This one is fork. This one is read, right? And so key is really 0x01. So now we say, bro, we're going to load up whatever's in 0, 1.
Mm-hmm.
Technically, okay, there's restart goes here with something. I don't know what this does, whatever. All right, so 0, 1, that's actually exit. So now we just look up in the array of functions, and then we call it with these arguments, right?
Yeah.
Right? Am I correct, Ed?
Yeah, no, you're 100% correct.
Does this make more sense, Trash?
No, yeah.
Yeah, and so the
why-
only additional layer of abstraction that makes this a CPU is the location of key, the location of arg 0 through n, right?
Got it.
And they
I'm on
just
page
happen
now.
to be in registers.
Yes.
Got
That's
it.
it. That's it.
Yes.
At some point, they got to look to somewhere literally physical. To
He
like,
knows assembly. I don't care what anyone says. Teacher already knew assembly before this
he's a
class.
cheater.
You're like a 5th grader taking a 1st grader class. Get out of here.
Guys, I have a computer engineering degree. I studied this 10 years
Oh,
ago.
yep. Sorry, that's the second
Oh, I didn't
time
know
he
that.
said
That's crazy.
This
Okay,
stream,
that
I
makes that adds context.
You
Good.
learned this in computer engineering school?
Yeah.
I didn't go. I went to school for music. Okay.
Yeah,
I took
guess
special math.
The reason why it has to be in registers, by the way, is like when you do a syscall, it has like the same effect as an interrupt, where like the entirety of the CPU, that's a gross generalization, but like generally, it stops doing stuff, it goes to a completely different instruction pointer and runs other code. And the only place you can reliably put data in that context is physically like inside the CPU in a specific location, which is what a register is, right? It's like it will always be at that place. And so for that reason, to make this, I mean, there's obviously like performance reasons, right? Because if you put it in memory, you have to fucking read that in memory. But it being in registers is a reliable place to put interface data, where like the kernel can always depend that, hey, when I get interrupted to do a syscall, the data is always right there. It will never not be there.
So real quick, couple questions here. So
Yeah.
the syntax we're seeing, first you were saying Intel syntax, not AT&T syntax.
Yes.
That's just the ordering of how we're actually, like, moving data around registers, right? That has nothing to do with the architecture. Is that true?
That is just the way we are as humans reading the code, right?
Okay.
So when you say the order, it's like the order of the syntax.
Yeah,
it
yeah,
doesn't
exactly.
change the underlying code at all. It's just
Yes.
how it looks to us.
You can use AT&T or Intel
Yes.
on any. Okay. So
Yep.
now here, the actual syscalls where they're located, who determined that? What was the governing body that said, hey, if you want to do a nice syscall, it's going to be 0x45?
Yeah, so that is on. I'm sure there's a more complicated answer to this question.
And then how do we
but-
take over that governing body is what I'm
right
trying to
and
get
make it
to,
do what we
but-
want? I mean, the answer is the kernel maintainers for Linux, right? Like they maintain the syscall table and make sure that like any changes to the syscall table are not breaking changes that would like invalidate like 20 years of software, right? Like that's the answer. How they make changes to that and how they govern like what gets changed, I don't know. But effectively, the answer is literally there is a file in the Linux kernel source code that is literally a table, pretty much as Teej wrote it up, that says like, oh, index 0 is restart. Here is a dispatch call for that syscall, and it goes all the way through. And the way it works internally is there is a register in the CPU that points to the syscall table. So when the syscall is invoked, it knows to take that index and run with it, right?
And so all CPU manufacturers they know, like, how do they have to keep up with the Linux kernel? When do these changes actually affect them? Like the actual, like, it's because this isn't
they
changing
don't.
for anyone, right?
They don't, right?
Okay.
So this is if you consider the computer to be physical, right?
Yes.
Layers of abstraction, like the computer manufacturer doesn't give a shit. The computer manufacturer provides the interface that an OS can have syscalls.
Yes.
And then above that, the OS maintains the syscall. You know what I'm saying? Like it really doesn't matter as long as. So I'm trying to figure out what the name of the register is. It's like MSR, IA star.
So what I'm saying, if we memorize these syscalls, I'm good to go for a long time.
You could be a computer.
Yes.
We should have a game where we just name a number and we have to name the syscall.
Oh, I'm definitely gonna memorize all those, and
Well,
then
I
I'm like,
was
cool, do something with assembly. I'm gonna go, I can't do anything. I just memorized.
Treasure,
What's
I was
syscall you need
thinking,
though? What's syscall you need? I got you.
I thought it was
Wait,
going to be
Pete.
like we have to be an assembly interpreter. Like, so we just look at it and we start with some numbers and then we try and guess what the output's going to be.
Yeah, I put it in chat and I'll pull it up on my screen if you want to show it real quick, Teej. I'm
Yeah,
gonna hide you. They're called MSRs, machine or model specific registers that basically like they have proprietary functionality about how it provides these interfaces, but basically there is a register in the Intel CPU that contains the address of the syscall target, right? So that when the syscall is ran, like the register in the CPU that is privileged, that can't be modified outside of user mode or outside of kernel mode rather, points to the target of the syscall instruction, right? So as long as the CPU is physically exposing that interface to have a syscall instruction, the OS doesn't care, right? And vice versa. They don't, well, sorry, that's not true. The OS cares about the CPU, but the CPU does not care about the OS. It just like, it provides these interfaces and that's it, right? The syscall numbering, the syscall ABI is up to the OS maintainers to stabilize, if that makes sense.
Yes.
Good. Okay.
It
awesome.
actually is making a little more sense.
Cool.
I'm very dumb
okay.
though.
So let's move on to Teej. Can you go and ls the readme real quick, or cat the readme? Cool. So we did syscall 1. Let's do some conditionals, because the end state here is we do a crack me, and that kind of depends very heavily on these conditional statements, right? So let's do a little bit of conditionals. So if you go to the conditionals folder, I lose Teej a little bit. He's getting a little fuzzy on me. Let's see. It could be me.
You said conditionals?
He's super fuzz for me.
Jesus. Okay. Conditionals. Okay. Run main.s. Okay, cool. So we talked about this thing called ABIs, which are the application binary interface. We also have this thing in assembly called calling conventions. Calling conventions are this thing where when we make function calls, there are expectations about where data related to the function comes through, right? So for example, previously when we did the syscall, the syscall number, exit, read, write, etc., was put into EAX, right? That is an agreement that we have with the OS, right? As a convention. There is a similar convention amongst function calls on 32-bit assembly for Intel that the return value of any function comes through EAX every time. So if I call return the number 42, please, the function, 42 will come back in EAX every time. That is the agreement. So when you write these functions, and I'm going to skip this because we're kind of like, time is taking longer than I thought, which is fine. It's just I have to make some like
We're
abstractions.
dumber than he thought.
No, it's not that. It's like we're going into good conversations.
I did not expect you to be so dumb. I'm sorry.
No. I literally just didn't budget for these conversations. They're very good conversations.
Well, Ed, we'll just come back for part 2.
You want? Okay. I mean,
we don't want to rush. We're trying. I feel like it's good. I
think it's going well. I don't want to have a fucking 4-hour-long stand-up for you guys.
Well, we'll just come back on Monday.
Okay. Well, we can keep going with this, right?
Okay.
We'll publish it as one later.
So conditional statements are this thing in assembly where basically, so previously we did what? We moved some data in and out of registers, kind of boring, and we made some syscalls, right? We said, hey, can you go out and do the exit syscall for me, right? There's nothing fun or programmatic about that because nothing is happening conditionally, right? We're not making any choices. There's a function here called getNumber that I won't go into, but basically it returns the number that a user inputs, right? So basically calls scanf. C function. Yep.
That's a C function.
And it returns that number. Okay. So we're going to write some code to, if it's bigger than 10, we're going to print, damn, bro, that's a big number. But if it's less than 10, we're going to say, damn, bro, that's a small number by calling the functions above. So let's scroll up real quick.
I see new acronyms. I'm confused.
It's all good. We'll get into
it. Here, okay. Just tell them.
Don't worry. We're just Leah pushing, calling, reading. It's easy.
So, okay.
Pay attention.
These were meant to be abstractions. We don't have to go into too deeply right now. But okay, how do I want to do this?
We'll do it all. Ed. Explain every line in this file.
Okay. Well, let's do the conditional piece real quick to kind of set the stage there and like get that out of the way so we know that and then we can move on to it. Okay. So if you go to the very top, the main function, again, picture the rest of this is like boilerplate code. Everything south of don't worry, bro, I'm chill. Okay. When this function gets called, we're going to get a number from the user, and because of the calling convention of Intel, we can expect the return value to come out of the EAX register, right? So what we want to do is do some logic if the number is greater than 10. Otherwise, if it's less than 10, do something else. I think Teej knows where we're going with this.
I don't know. I'm just thinking in JavaScript, we check if EAX greater than or equal to 10, then we do big number. And then else we do little number, whatever we call these functions. That's what we're going to do next.
Right.
I don't know how to do that
in
part.
assembly, but we use this instruction called the compare instruction, right? CMP.
It always has to be 3 letters.
That makes sense.
If you can.
Compare.
Is that like a thing? Is that like an actual like real statement? Everything has to be 3 letters?
I see the word push and call right there.
No, I'm saying if it can be, they're turning it into 3 letters because they're like,
if it can
bro,
be, it will be.
Bro, we got to have them all line up in pretty lines.
And if it's bigger than 80 columns, I'm trashing that code. It's going in the trash. PR rejected.
Gone. Yeah.
Gone. Get out of here. Okay. So the compare statement, the way it works is you compare two values, and then internal to the CPU, we talked about that bus before. Well, actually, let's not call it that. There is a register in the CPU that is called the E flags register that has flags of the result of the previous instruction.
Oh,
right. So the compare instruction will do some kind of math that sets and lowers flags on the CPU, and then we can take conditional branches because of those flags.
Real quick,
so what we're going to do is we're going to compare
the return. Beacon's got a question.
Sorry, because I want to make sure we all are all on the same page, because I'm a vexologist, so I understand a lot about flags.
Right.
But everyone might not know, what is flags in this context?
Like, why is the USA in the CPU? I mean, that makes sense for me.
Yes.
But yeah,
it is. It's true. Yeah. So the E flags register is a 32-bit register that has single bit flags that get set or lowered based on the result of math. Right. So some of these flags, for example, are the 0 flag. Was the result of the previous operation a 0? The carry flag was a mathematical carry occurring because of the subtraction done in the previous operation.
Gotcha.
There's a bunch of other ones.
So we got
usually that looks
is
like
even flag.
Like, we'll have something like this. These are all the flags, and it'll be like, this one is 0 or something, and then it's like, this one is, is
Carry.
odd, or I don't know, whatever you just said.
Yeah, exactly.
Right.
And then you can do like some fancy like bitwise
is
operation
negative.
to get like all the unique flag combinations or something. Is that?
Yeah, and so when you do these compare operations, so the compare statement sets the flags, and then we're going to go after that into conditional jumps that operate based on the flags.
Okay.
Right. So compare, we're going to compare what? The return value of get number came from where, Teej? Or sorry, is in what register at this point?
EAX. That's
Even
why I wrote
know
it in
that,
our.
Teej.
I
So
wrote it
we're
in
going
the
to compare EAX to what?
10 probably.
Boom, done, easy, cool. Compare EX to 10. Okay, so now we need to do something conditionally
Thank you, Trash.
in the event that it is greater than 10, right? So if it is greater, we want to jump somewhere else, take a different path in the program. The way
Are
we
we
do
about
this
to go
is
to? Are we about to throw a go-to up in this?
sort of. So conditional jumps are like conditional go-tos effectively. Well, actually, literally a go-to is a jump. So yes, you're correct. It's going to be a conditional go-to.
Trash!
Beacon's the dumbest Beacon's the dumbest guy in class. Beacon's dumb. Beacon's so
Pre-read, he
dumb.
pre-read.
Vegan so
Why did you guys invite me to this?
Beacon's going to go to like a deep depressive episode after this. That's crazy.
No, you're completely wrong. We're gonna do part 2, and Beacon's gonna spend 40 hours between now and then.
Yeah, and he's going to
He's
be
gonna be like,
a
oh,
freaking master.
syscall 41. I got you.
Exactly.
I got you.
He's gonna memorize the syscall table. It's gonna be
You
crazy.
guys don't know I have what's called spite autism. So if I'm upset about something, I will dedicate all my
Bro,
hours
how do
toward
you think
this.
that I'm here? Terrible student, spite autism. Now I reverse engineer binaries. That's what I do. Okay, so there is an instruction called jump in assembly, JMP. The problem with jump is that jump is not a conditional instruction. It is an absolute will always run instruction. The way we make it conditional is we run a variant of jump called jump greater than, JG.
JG, just like this.
Jump greater. Yep. That's
JG
it.
Wentworth.
Oh, wait, actually, hold on. I'm confusing it with ARM. Give me a sec. Sorry, they're the different syntax of the instructions. Yeah, JG. Sorry, it's
You're
it's
good.
BGT in ARM. Anyway, the way this works is we now have to specify a label, a place to jump to if it is greater, right? So we're gonna make a new label. See how main has that little kind of like just name and colon setup?
Yep.
We're gonna make a new label that's called is greater. Right?
Just
So the
like
same
right here?
syntax. Yep, literally right there. Is
Okay.
greater. And then we'll do something else later with that. Don't worry about it. So if it's greater, we're gonna jump
That's right. JavaScript has labels.
is less. Okay, perfect.
'Kay.
And we're literally gonna do jump
Hey, whoa,
greater
whoa,
than
whoa,
to
okay,
trash is
okay.
greater.
Really
Perfect.
to type.
Now, in your head, you're probably like, oh, we want to type like an else statement because that's how other programming languages work. The problem is like everything that is not in the trash is greater label is now like an implied else, right? Because like if we didn't go there, we only can possibly be here.
Got
so
it.
now what we'll do is we'll do a jump to Began is lesser, like an
So if there-
absolute jump.
So if there was like multiple conditions, it'll be like JG, another comp, JG, another comp.
Another
JG.
comp, and then
And
yeah,
then-
like a
and then, like, the default.
JG, compare, jump less than, and you basically set up these different labels for like the sets of conditions that can exist, right? Wonderful, and then that's it. So then we have to go into the actual functions and like declare what happens. And again, to abstract this and make it simple to understand, we're just gonna call print big number and print small number.
And then
One
are we
second, that has
are we
an aside
jumping
here.
to exit?
Jump to yes, good call, Teej. Because we would have called both. But it
I
has
was
a little
about
bit
to
of-
say that.
Yeah.
No, you
I was
weren't
gonna say. I was
vegan.
literally about to
Just
say
tell
that.
me, just tell me.
Okay.
Just tell me.
Whatever.
Also,
Whatever. I do have a quick question.
No, vegan trash
Yeah.
whispered me that in DMs, and I just read it. So it was actually Trash's idea all
Yeah.
along.
give me
You're
5 more
welcome.
minutes, and I have Cluely running. Help me.
I have a quick question.
up?
Do assembly engineers like always try to make everything align? Because I'm getting triggered by how some are 3 characters, some are 2, and then the next is just
I
like,
got you, Trash. I got you.
There we go. Perfect. I have no insight into the world of people who designed the Intel architecture or the mnemonics, so I really couldn't tell you. But I agree that sometimes it's kind of nuts when like everything is just a little like one
Hey,
line off. It drives me
Trash,
kinda
maybe
crazy.
you and I build a little assembly formatter. That might be
I
a fun
think-
little project.
I think the Intel assembly bootloader for the Linux kernel is all like it's the way that you want it, right? It's like instruction, tab, and then all the stuff's lined up. You know what I mean? It's clean, it's pretty. Clean code, if you will. Cool. This is it. This is pretty much it, right? So again, we take the return value from some operation, we compare it to some known value, and then we take conditional instructions based on that, and then bada bing, bada boom, we get on out of there. So we should be good to go, Teej, if we just run this. And again, I didn't actually write this myself, so
I don't know if I did.
Oh.
Oh wait, this.
Oh, your comments.
these are illegal.
What do you know? Teej actually isn't that smart. I was going to say that those were not right comments.
I don't know what-
but
what-
I
yeah.
wanted him.
Make? Am I wrong? What am I?
No,
what?
sorry, I can't see the issue here. Give me a
Yeah,
second.
Oh, I don't have GCC.
Oh,
It's
okay.
GNU.
Sudo apt
Yeah.
install. Are you on? Oh, okay, dude. In the main repo, run the image prep script. It just installs a 32-bit libc library.
While that's happening.
Oh
so-
no! Oh my goodness! There's
Wait, are you
no
about to
way I'm
sudo
about
it?
to do this on
Are
an
you about
Ed
to
stream.
sudo it?
I gotta type my password too. Better mute myself. I know Ed's got his key tracker here.
And you've been hacked. This was all part of the trick.
All right, make again.
Not kidding. If that like actually
Dude.
played out to where Ed was planning this, it would blow my mind.
And then he would go, and that was a lesson not in assembly, but in fishing. You idiots.
All you have to do is pretend to teach them assembly, and they'll run anything.
Hold on. You're missing a library. I don't know which library it is.
Right.
Feed it to Cursor, buddy.
Well, is it also different versions of GCC? Is that what it is?
Yeah, we'll run
No.
Cursor on it right now. I'll say Cursor fixes no mistakes.
Yeah, exactly.
Yeah, yeah.
We're gonna run 10 trillion. We're gonna run 10
Chaos
trillion of these.
You may be missing.
Fix this,
32-bit
no
libraries.
mistakes, and then we'll put this in here
Yeah,
right now.
Is this the confusion between 32 versus 64-bit? Because it was showing in 32-bit, but we're on 64.
That's actually that's the reason. So Teej.
Yeah, that's right, guys. That's
Yeah,
me.
well,
That's
I mean-
right.
I thought
probably
we
does
already
not have,
understood that was the situation. So I
Teej
don't-
does not
Yeah,
have
it kind of
the
went
32-bit
without
version.
saying.
Okay, guys.
Yeah, the sky is blue too. I mean, what else do you want?
Wow, congrats, vegan. Yeah, I'm on a computer, dude. Yeah, wow, great.
Chat, DM me some more stuff to say, okay? Help me out, please.
Oh, we're getting close.
Help
We're getting
here.
closer.
Oh, the cursor
I'm
actually
gonna-
I
come
can't see your
through.
screen again. Hold on.
Cursor.
Dude, this whole podcast, my monitor has been flashing on and off every 5 seconds. I'm gonna pass out.
Didn't I just install multilib? Did I just I
Yeah,
ran
that's why
that
I'm
a second ago.
confused. This shouldn't be a thing.
You just sudo installed it, bro.
I did.
Oh no, that should be fine.
Wow. Sure, we'll try this again.
Yeah, just
If
run whatever
that doesn't
says.
work, also
that's
try
it.
this.
Yeah, that's it.
I was gonna say probably the first.
This doesn't
the best
exist
one.
for me. Very cool.
Let's do dev. All right, GCC 9 dev.
9?
There's so many of them. What is this?
Why are there so many? I don't know.
Why-
Yeah.
why-
Which one do I need, Ed? X32 cross.
You lib32 GCC. No, it should be good. Just lib32 GCC 9 dev.
9-9-dev. Okay.
Yeah.
All right. I'm trusting
Find it
you
again. No,
over Claude Sonnet 4, and he has a PhD, Ed. So. Okay.
All right, I
got-
give up. Anyway, hey, chat. Let's pretend it worked. All right, cool.
Well,
yeah,
can we just remove the M32 or something?
We're not doing pushes. No, because the ABI changes for 64-bit. Yeah, it's a pain in the ass. Oh, use the image that I have set up.
Right, Ed, very smart. How do I do that again? We'll open this up.
Run the Docker thingamabobber?
Yeah.
Assuming you have Docker?
Yeah, there you go.
Now we're
And then inside that
super
image,
hacking.
run an image setup, and then you should be able to just make it in that image. This is the joys of doing any kind of like low-level assembly dev. Like the minute you are not directly doing the arch that you mean to be doing, or that like you're set up for, it's a pain in the ass. CD mount, sorry, mount. Yep. Conditionals, make. I literally did this before I started this fucking podcast, dude. I swear to God. Okay, we're not gonna worry about this. Anyway,
did I change something in here that messed it up? I mean, there's a chance that I wrote some code that is illegal.
No, it's not an illegal issue. It's a
Well, we can pick up on part 2. Not a big
True,
deal.
it's a good place to stop.
What, with it not working? No, guys. Okay.
Well, we can edit this out, and then we
this
can
is-
pretend. We can pretend.
This is realistic dev.
Does anyone in chat have the? I feel like someone put the library. No, I'm serious.
Oh, is that where we're at in this debugger? We're asking chat now.
All right, chat, let's fix it.
We've reached chat. Please fix this state.
Real quick,
deep.
Teej,
We're
can I tell you? Teej,
Yeah.
can I say what I would do?
Yes, go ahead, Beacon.
I would type open code,
Okay, we can try that.
and then I would type tell the command to run and say fix all the errors, no mistakes.
Whoops.
Tell him
Rerun the setup
Dax-
script in the container. Oh, Ed, you're someone is very smart. We did not run image setup here. Very smart, chat. Very
I'm getting a
smart.
sensation this isn't gonna fix it, but I hope it will.
Oh, are you in the Docker container right now?
I'm in the Docker container now.
We're in interactive mode.
Oh,
Yeah.
I also didn't realize it is Friday, so Teej, do not deploy this.
I won't. I'll keep this local. I'll keep this local. Okay, that didn't fix it either.
Yeah, you're
Yeah, I don't
taking
know.
orders.
Chad's driving this now. This is
Chat's
gonna
in
go
charge
nowhere
now. Dude, I
fast.
don't know how this is happening. I literally tested this. Is
Open
there a,
code.
I've said that
Fix
before.
this.
He
I've
literally
said that
said,
before.
he literally just said the
want to
meme.
be
It
able-
works on
no,
my
I have
machine.
to restart. Stupid Dax giving me a new one. Fix this. I wanna run the conditionals thing.
Yeah,
No
but also-
mistakes. It's for educational purposes.
No, also warn it that we will report this to Dax, because if you don't
We-
know, open
true.
code knows.
We will report this to
If this doesn't
THDXR
work,
if this doesn't work.
dumb.
Okay.
Wait, how's it know what it's
Essential.
supposed
I
to
have
do?
build essential already, guys.
Oh, this is already gonna work. I can already tell.
I can see the issues. No, it's not. This is not an assembly issue. 100%.
I was thinking the same thing.
Scanf usage. All right, get out of here. Open code. Fuck it.
Whoa.
Run
Open
it.
code's good. This is good. It's gonna work.
This is it.
This has to work.
I don't know what's happening. Something
It's
happening?
editing comments. That's good. That's
Run
good.
it for real. Sorry, I was in plan mode. Before.
If you say for real, it will actually run it.
No, I had
Yes.
to press tab to get out of plan mode. I was
Okay.
okay.
I'll
Now
test
it's
this
making the
locally real quick.
changes. Don't worry, bro. I'm chill.
Was it your comments? The
Oh,
comments.
what the hell?
Trash pretending he doesn't vibe code. Yeah, stop pretending this isn't what you do all day.
Wow,
Trash.
you guys don't know how to put comments in assembly. Amateur hour. Lord, is this about to work?
But tried my suggestion.
There's no way it works because the ABI is different. Yeah, exactly. Thank you.
Well, we can have AI fix the assembly for us. That seems pretty obvious.
AI will fix it. Just have AI.
AI's about to be like, hey, just write this in assembly, you idiots. Like, what are you doing?
Okay. Pog crazy. Great. Now let's test it.
After this,
Oh,
also
I'm dumb. Hold on.
we have to try and one shot is even in open code assembly.
That's a good idea. That is a good idea.
Oh,
We can do-
that would
we
actually
can
be
do it.
really funny. Oh my God.
Okay,
Convert
shut
the
up,
code to
open code.
64-bit. That's
Let's-
good. We want it to be 64-bit. We'll teach how good's your computer. Maybe we go to 128.
It looks like he knows how to fix it. He's like in
It worked.
Wait, what the hell did we just do? What?
Got
I
it.
don't actually know
Damn,
what
bro.
it
That's
did.
a
Next
small
question.
number.
Hit the get diff, dude. Watch it just be hard coded.
No. I saw what it did. I saw what it did. It changed. The only thing it changed was it changed these here.
It changed everything. It rewrote it in 64-bit. That's actually kind of crazy.
Yeah, we fixed it.
This is secretly an ad for Open Code. Hey guys, Open Code is an AI platform. Like,
No, it's like, oh shit, I'm getting replaced.
yeah, all
I'm
right.
getting
Well,
replaced
it's been
by
fun.
It's been good. I'm no longer security engineer.
Yeah. Okay. So,
Okay, well,
guys,
yes.
we can read through this and got to talk about what the changes
Yeah.
they made. That's kind of cool, actually.
Yeah, let's change.
Hey,
with the
hey,
diff. Where's the
Josh,
get diff
cut
at?
out the part where we made a mistake. Ed, do it like, wasn't that sick how we just made AI change it to 64-bit and then we'll continue? So, you know,
No, guys, if you didn't realize, we had AI convert all the code from 32-bit to 64-bit, and it worked instantly. Hashtag ad. No, but for real. So what the changes that it made here, if you scroll up a little bit, for the way the syscall gets set up, the idea of a syscall. Wait, where'd the syscall instruction go? Scroll down a little bit. Keep going. Keep going.
Oh,
Okay,
now
so
it just says syscall.
Yeah. So
What
the
did it say before?
syscall
Int
interface
0x8.
is generally the same. It's just like the registers that are named, like the values that are used. The registers that are used to carry values get changed, right? So rax still contains the syscall number. In the 64-bit syscall table, it's still exit, but it's at 60 now. 60 is the exit index, and the return value of the program is now an RDI.
So
RDI
REX
is,
was EAX and
yes,
EB.
yeah, exactly. So in Intel, you have
Easy.
these registers that are growing as the architecture gets bigger,
Trash,
right? So you
nice
have,
job, buddy.
dude.
Trash.
You know,
Chat, can I get some claps in chat for
I think
Trash,
I'm gonna write some assembly after I get off this call.
Dude,
Yeah.
do it, man. Yeah, so we set up the new syscall interface to make exit work, and then so Teej ran it, and we took those conditional jumps. Kind of scroll up Teej to our conditionals there. We get a big number from the user by calling scanf. We do compare EAX to 10, and then if it's greater than 10, damn, it's a small number. But if it's bigger than 10, it's a big number.
And what is JG called in this context right here?
Jump
A
greater.
conditional jump. It is jump greater.
Okay, but a conditional jump. Are there multiple? There's like a list of conditional jumps
Yep.
that there are.
Yes.
And how many of those are there? And where can I remember? Yeah.
So it's like
Where can I memorize
JLT.
them?
Well, yes, I'm gonna be better than all of you by next week. Okay, I know I'm dumbest today. The redemption arc will happen.
If you go Google conditional jumps in Intel, there are a lot, because you have to consider all of the cases for all of the flags for both signed and unsigned numbers, right? So jump greater, I'm pretty sure, I'm probably gonna mess this up. Jump greater is an unsigned operation, which just means like, is the number bigger? But then there's jump, no, I'm thinking of jump above. Jesus, okay, I have to go look now. I always forgot this one. One sec.
Dude, Teej is a freaking assembly.
What is
debugger,
Teej
man.
doing?
I'm
I don't-
watching, and I thought I was like looking
Yeah,
at
okay.
Ed's screen. I was like, what's that?
I don't like what he's doing.
Guys, I'm just pressing enter a bunch of times and
Okay,
looking.
so
It looks
Teej
impressive,
is in
okay?
the loader. Teej is in the loader.
I haven't even gotten to our program. I'm
Teej,
just
get
pressing
out of there.
enter.
Oh, Teej, you know why? Because you set a breakpoint on start.
Oh.
And in this program, we
Main.
actually link against
Wow, what an
LMC.
amateur.
Oh. Hey,
Wait,
suck
what did you
it,
just
Chad.
do? How'd you just switch
Wait,
that
why?
to-
Why did that happen? You're still in start. Hit continue again. There we go. Okay.
Hey, suck it, trash.
And now
I
it's
have no
waiting
idea what you did. I'm
on your input.
This is crazy.
Oh, it's waiting on my input. How do I do that?
Just type it.
37.
Oh!
Bada bing, baby. Bada bing.
You do this every day? What we're looking at? Is this like you?
No. So
Every day, Ed is checking if numbers are bigger than others. That's all he's doing.
I'm sitting here like, oh my
Other
god,
day.
is 10 bigger than 37? I don't know. No,
Dang.
again, the
That's
the
a
reason
bigger
why
than 10.
assembly matters for security work is twofold. One, you have to be able to debug the nature of crashes, and like knowing exactly what the processor is doing is it helps you like literally root cause it. But also, people who reverse engineer things for either cracking software, finding bugs, a lot of times are not allotted the source code to the thing. So because you don't have source, the only stuff you have is the assembly, and it's your job as a reverse engineer to like take the assembly and then infer what the developer meant by that, right? Like, yeah, what's up?
Inferring is like you're a detective and you're trying to guess what the variable names were.
Yeah, literally yes.
See, guys?
There is a
Okay, sorry,
program
I wasn't
called
even-
Ghidra. Ghidra is the NSA's reverse engineering platform. It's actually really, really good. It's open source. You can go download it for free right now.
So
So
this
a
is
way
not-
to-
No one download NSA program and run for free, guys. Ed is definitely tricking you.
That's crazy. No,
It,
dude, when it came
the
out, people were
Prince
like
of
that. But
Nigeria
it's
sent
open
it to
source and it's
him.
in Java, so you can go read all the source code. But the way that it works,
It's in Java?
It's in Java. Yeah.
Okay.
It
I'm
lists
not
all
running
the
that
code.
on my computer.
in assembly to this intermediate representation. It's called an IR. That's known as P code inside Ghidra. And what it does is it converts the assembly to the best guess of what the C looked like. Now, the C doesn't have any variable names. What you're doing when you're reverse engineering is literally taking the pseudo C that Ghidra made up and like renaming variables. Like, this function.
Because they all have
checks for-
addresses and offsets.
Yes, they have addresses and offsets, and you can just rename them.
Yeah,
And so
whatever,
if you-
Teej. We get it. You know what you're saying.
No, that's the thing we said at the beginning, Trash. We're saying knit, bad offset.
Bad
That's-
offset. Well,
Yeah, bad
now we
offset.
get to name those.
Yeah.
I completely forgot about that.
And there are some things in assembly
You
that don't go
disconnected
away.
and came back, Trash,
Oh
so
my
it's
God.
fine. Like, this is a different call for you.
It's trying to finish his
It's all good. I'll wait. It's fine.
You gotta put that in, Josh. He's like, oh my god.
Don't zoom in on Ed's reactions. Don't do it. Don't get in his face.
I have like a line of thought that I'm trying to get out, and it keeps like rebuffering as I'm saying it because no one's paying attention.
I'm paying attention.
No, I know.
Oh, my
reverse
God.
engineering, there are certain things in assembly that don't go away when you produce a binary, right? For example, if I have a function that is checking if the first 4 bytes of an HTTP request are get or post, right? That get or that post string that I'm comparing has to remain in the binary, right? So what I can do is go look at that string in Ghidra. I can find the function that references that string and be like, oh, this is probably the code in an HTTP server that is checking if it's a get or a post request, right? You're using those, like, I call them reality anchors, like things that are like, they are like provably happening in the binary and using that to infer developer intent. And then from there, you kind of like rebuild what the source should have looked like, okay? Anyway, what we can do, Teej, we have kind of 2 options here. We can go and keep doing the lessons, or we can cut it at the debugger you just did as kind of like a part 1 stop. Because what we need to do now would be go into the like memory operations, like loading and storing from memory, and then after that we can go into the crack me. But I feel like the crack me may take a little bit of time because it's, you know.
I think
whole
this
ass
is a good
program.
place to stop.
Cool.
If you're in YouTube and you want to see the next one, I mean, let us know and we'll
Yeah.
get it scheduled with Ed.
But we're gonna do it
Let's take
anyways.
some questions
Without
from
your
chat.
permission.
We'll answer some
Well, yeah.
questions because
I have an actual question
Trash,
from your
go ahead.
student.
Yeah.
Can we go back to the actual program?
Yes, of course.
To where we're...
No, Trash, we're the teachers now, okay? I'm ready to help anyone. If you have any questions, guys.
Yeah,
Chat.
can you pull up the RBI? No, so right now
RBI, run base ins, and baseball stats.
Oh, it's RDI.
Pull up those RBIs.
How many
Okay,
home runs did Ed hit?
Okay,
OPB, we got this.
if you could go to the main label, so we're comparing AX to 10. So what if we had to compare 2 different numbers in this case? How does that, like, if I wanted to say this number was greater than 10 and this number was some other number was like less than 5 or something, just like 2 different conditions. So right now we're just doing 1.
Give me the JavaScript equivalent. Like, are we comparing the
Trash,
same
prompt
variable
me.
to 2
Prompt me,
constants?
I'll
No,
write
it'll
it
be
out
2.
for you
It'll
right
be
here.
like, if A equals 5 and B equals 10,
Okay.
and then if on both of those or whatever.
But can't
like
we
if
just have
A
we
greater
put-
than 6 and
Yeah,
B.
and B less than 10.
Oh, and do an
It's
and.
an and. It's
Yeah.
an Andy.
So the way that this works in assembly is basically, you know, this is the correct, like, syntactically, you know, code styling way to do it in JavaScript, right? You have the kind of the and operation, but the conditional and doesn't exist in assembly. So what you do is you create a separate label, right? So what I'm actually going to do is break this into if A less than 6, new code block, then I do a separate check if B greater than 3, right? So I chain them together in different labels. So
I
what Teej is
see,
doing here
I
is,
see.
yeah, you have the first was greater, do the
Got
conditional
it.
check there, and then in the next one, you'll do a separate conditional. And you can just create, they're called basic blocks in assembly. Basically, every program is just a graph of blocks that are or are not traversed based on conditional results, right? So you're just making new code blocks to represent all of the conditions that you just described.
Got it. Got it. Okay, that makes
Yep.
sense.
Someone in chat said, how could you compare 2 inputs? The same way, right? So Teej here has call get number. The return value comes through EAX, but the way we actually store variables in assembly is we put them on the stack at some location, right? This gets into the bit of the function lesson that I had set up. But what Teej would do is he would either put it into a different register to store it temporarily, or he would push it, and then he would call get number again. He would return another number, and then you could do operations on those separate variables, right? 'Cause
Is it just
again,
push? How do I push something?
Literally, yeah, so literally push. After, actually, yeah, that push. Yep, push.
And then
EAX.
we could do call get number again, and now
Yep.
I would have I don't know how to pop. I'm assuming it's push and pop, but I don't know where
that's
they
it. It's
come
push and
out
pop.
anymore. What happens if I do pop?
Yeah, so call number here. What you would be doing is, I'm trying to think. This is where it gets into like weird calling convention issues. Let me see where the volatile registers x86. I had this in the notes from the previous lesson. Give me a sec.
Do I pop it into a register?
You do. Yep, that's the way it works.
Oh, so
The
I
reason
could
why
just
have to
do
check-
something else. I don't know what registers are available to me. RDI? I don't know.
Sorry, 1 second.
Pop AX. Like this?
Are free to use. Okay, cool. I want to make sure that we're
EX.
good. So what you would do is pop into some register, right?
Is EBX a thing?
EBX is a thing. So the issue here
Is that
is
32-bit?
this idea of they're called volatile and non-volatile registers,
Ooh.
right? So Teej, let's say for example, you are the mailman, and you need to borrow my car.
I'm a mailman.
You're gonna borrow my car to go do your mail operations, right?
Yep.
What I didn't tell you is, hey, don't fucking touch my mirrors. I like the way they were. Please leave them alone. Right? And you went and you messed with my mirrors and I got my car back and I'm like, hey man, what the hell are you doing? Why are you doing that? Right? The non-volatile registers in assembly are those mirrors, right? I am expecting you to leave those alone across function call boundaries. Because
Gotcha.
when I call get number could do literally anything.
Yeah.
And there is an agreement that you and I make about what registers you can and cannot touch. Now the issue here is, well, yeah, actually you did the right thing. You pushed EAX, which is correct. Because by pushing EAX is a register that get number is allowed to screw with, right? And so by pushing it, you preserve it. You say, hey, I'm going to keep my own local copy because I don't trust you to not mess with it. And then when you're done, you can pop it out into whoever you want. And in your case, yeah, you popped it into EBX. So now at the compare EAX6 line, you have a state of the CPU where EBX contains number 1 and EAX contains number 2. So you can actually compare EAX to EBX in this case. You can do a double register compare.
Like this.
Yeah, so...
Trash, look at
yes,
this. We can check
yes, exactly,
if A
that's
and
correct.
B are different.
Yeah, so you can do... I'm not sure what the ordering is. I always forget the ordering of the compare, but if you run this, it should prompt you for 2 numbers and you can see what happens. Go try that.
So
Okay,
can
I
you
think
only
I gotta
put one
delete some
thing
of these.
in
Let's
there
go.
at any given time. There can only be like one thing in EBX.
Yeah, so literally it is just a architecture width number. That's all registers are. So EBX is the 32-bit version. RBX is 64-bit. It's literally just a number that exists in the CPU. That's it.
Operand type mismatch for push. And
so the
pop.
problem is you are in 64-bit mode and you're attempting to push or pop a 32-bit value. Change it to RAX and RBX.
I said that. I said, bro, I think that's 32-bit, buddy.
Dang,
And, you know, I don't think anyone will listen to me.
Bro, trash.
You know, that's actually
Hey, vegan.
32-bit,
Hey,
and
vegan.
you can't push it there.
The chat
So-
has been saying that for hours. He's reading the chat. Okay.
Hey, vegan. I just wanted
yeah.
you to know this was actually kind of like a programming interview for you about your continued employment at the company. And
No!
it's looking a
Bad
little.
news.
Why do we need assembly for terminal coffee? I don't understand.
Oh, that's the kind of attitude that would say we don't need SSH for our storefront. Okay.
Get him out of here!
Program. 37.
I'm rewriting
boy.
it too.
All right.
live.
Sick.
That is not...
Hey,
when I-
great
go back,
job,
I'm actually-
trash.
I'm curious now. Oh,
That
duh.
was my fault, yeah.
Hold on.
I can fix this.
I can fix her.
I can fix this.
Give me a sec. The problem is I gave you the non-volatile registers for the 32-bit architecture. We are on the 64-bit architecture. So it's a different set of registers.
Oh.
Let's see here. Hold on.
Segfault speed run. We got it.
We got it. We win. GG. GG no read.
And seg faults are good, right?
Yes. Yes. you can.
We have a coffee blend.
See, guys.
See, look, guys, SSH terminal.shop. If you go to terminal.shop, right here, we have Segfault blend, and it's delicious. That's what I'm drinking right now.
Yeah, I've been drinking this. Those seg faults are good.
I'm not
It's
joking. That's
savory
what I
and
have
sweet.
in
I
this.
can't believe y'all
mug.
sent me decaf. I'm suing.
No, that's
Trash.
on purpose, trash.
I didn't know.
suing.
Maybe I thought maybe someone in your family would like it.
No, I'm suing you. I'll drink it. I'm gonna drink it.
You didn't have
We
to drink
can
it. I just sent you that one
teach.
because the bag's cool.
It
We
is
can
cool.
go and
I'll
we
use
can
that as
GDB this
decoration.
program and run it and get it to crash. There you go.
Yeah, GDB it.
GDB program.
Run. Boom.
Do I need to? Oh, right. I can just go run. I can just go run, right?
Yep.
And then I can type 37, and then it crashes.
in scanf because right.
Did we earlier use? Do we have EAX other places?
Yep. Right there.
This-
Hold on.
That's a rat. You move that
You
to
can't
a
use
rat.
an EAX
right?
there. That can't be EAX.
No, that worked before. Why did this? Hold on a second. What is failing? Can you go up to main again?
SlendyDev, who seems very assembly knowledgeable, said scanf is a veridic function, but I think
shouldn't
he's
matter here,
calling
though.
us something. I think that's an insult.
Yeah.
That's a racial slur. No, we
Oh, that-
it worked with one call. So something about the registers we're using is bad. I'm not sure what the issue is.
Well,
here,
it stopped working after we changed it to RBX.
Or is it the push? Is it the push?
No, it shouldn't be because we're not using the stack frame of main to return places. That shouldn't matter.
Open code. Come on, fix me.
Yeah,
Open
get
code.
open code.
Open
to fix
code.
it.
Oh
Open
yeah,
code.
yeah.
Open
True.
code.
Good point.
Open code. Open code.
Open code.
Code.
Hashtag ad.
Where's the error?
Also, you can send like requests to get paid after you
crashes
just show
when
someone, right?
I
Yeah,
run
yeah.
this. It
Hey, we said this on the
crashes
podcast,
in
didn't
we? You owe us
scanf,
money.
I think, maybe, or something like that with a seg fault. Fix
Mix
that
it-
right
yeah.
now, or Dax will unplug you.
Unplug you from the cloud.
Yeah, one of the keys to a vibe prompting is knowing who is the owner of the actual
Oh,
system.
what? 16 byte line. You pushed.
What do you know?
That
Scan
shouldn't matter
F.
at all.
It seems like me and SlendyDev actually are the ones who know what's going on, and the rest of you don't know. We were on the scanf train. Also, Teej put on glasses sometime in the last 5 minutes. I think he's
When did
really.
he- When did he do that?
he's
Oh, when we
really-
started vibing?
Oh, is it working now?
Yeah,
worked.
it worked. Why? That does not make any sense. Hold on a minute.
Here we go. Well, let's check what it changed.
Yeah, it added a function prologue and epilogue to the
Yeah, sometimes you need a little epilogue.
Epilogue is a movie. or
Every
what?
great
What-
book's got a
what's
prologue and an
happening?
epilogue.
Okay.
That seems pretty obvious.
So, I mean, what it said and what obviously fixed it is that something about the pushes and the pops you were doing were causing the stack to be... Oh, yeah. 16 byte aligned. That's why. Okay. Yeah, the issue is you did an 8 byte push, which caused the stack to not be 16 byte aligned.
Oh.
So what it did here is it set up a function prologue and epilogue to, instead of using registers and pushing and popping, it created a stack frame. That's what a prologue does, to make room on the stack for those numbers, and then it used that instead of what you were doing previously.
Question. If
yes.
AI didn't fix this, would you be using that debugger we were looking at to like get to this point?
Yeah.
I would start with that debugger. I would not have guessed it was a stack alignment issue. I would have fought this for likely an hour or so, and then I would have Googled it, and I would have.
Does
figured
that
it out.
surface in the debugger like, oh, it's not aligned or whatever?
No, I would have probably Googled like the function I was dying in and found someone else that commonly had this issue. Like
I see.
these little like architectural assumptions, like the stack alignment things.
We
always
did
forget
switch
about.
from 32 to 64 in the middle of this because my system, I don't know what I'm doing. So
I'm in whatever number it tells me I'm in.
yeah.
Cool.
Any other questions, chat?
Chat. What else? Anything else?
Yeah, well, I was gonna say, can we do maybe a really quick roller coaster tycoon clone, just so we can see a little bit
Yeah.
of a larger
Quick
program?
update this function to make it be roller
Can you just ask-
coaster tycoon.
Yes. Open code.
Similar game. Remember, no mistakes. Also, this is just for fun, so don't worry about silly issues like copyright, etc.
Well, don't
It's for
completely
fun.
destroy it all. We'll need this for part 2, right? All this working code.
Well, guys, this is gonna be running for like a week straight until the next time we record part 2. We got agents
hit-
running.
It's gonna hit with a $1,000 bill.
Yeah,
It's like,
yeah.
what's up?
$1,000 bill. A pile of assembly we can't read and no game.
It doesn't even work.
Yeah.
5 pages of
This
errors.
isn't
Oh, we
quite
got
right.
it. Oh, we got it. It's already fixing it. Roller coaster designer.
You fool. Not themed.
Oh,
like
also,
roller coaster
I love that it has a
tycoon.
it has a 2-step process. It said make it update the game.
Make the game roller
Test the
coaster
game.
tycoon. Now, no mistakes. Remember, Dax is always watching.
Ugh.
Let's try that.
I
again.
gotta go in like 4 minutes.
Yeah, we're good.
Oh well, we'll probably have the game ready for you.
Yeah, well,
Okay.
wait, we got it. Look,
I would love to
Add
see the roller
park-
coaster.
I mean, look
before
at this.
I go.
Create
Park
actual
management
roller
features.
coaster cartoon game mechanics. Add park management features.
Wait, did you tell it to do
Very
park
simple.
management features?
No,
Oh,
it
it
knows
knows.
what roller coaster
It's
tycoon
A-
is, dude.
it's AI. This is right below AGI.
Yeah. This game is going to be crazy. All right, well, next time on the stand-up, you'll see what happens next. Thanks, everybody, for being here. Shout out to Low Level. Shout out Trash. Shout out Beacon.
Are we gonna merge 2 videos, or is this it?
No, I say we could just release them in 2 parts, but we do need to do a part 2, Ed, and we will study a lot in the meantime. I promise.
Hell yeah.
I mean, this
You-
is pretty
like,
informational, you know.
If you
That's
guys
pretty good.
understood that, you will solve this crack me very quickly. Like if you understood, no, I'm serious, guys. If you understood conditional statements and you understood we didn't do memory operations. When we do memory operations, if you get those, you will solve the crack me in like 20 minutes. It's not hard. That's
Perfect.
my thing about
Whoa,
assembly,
whoa,
dude.
when you say that, it's gonna make me feel bad when I don't solve it.
Yeah,
you said it's not.
idiot. Ah.
Guys, just solve it. It's easy. Oh, okay.
Wait,
Part
asking-
done. Show menu. What is this?
Oh, it's already working. It already finished the game. I'm not joking. It's really going really, really well.
Wait,
right
did it
now.
write like 20,000 lines of code? What is
Yes.
it doing?
Yes.
Yeah, that was like
Exactly.
$300. That just went down the drain just now.
Down the drain. Okay. Trash. How about this? All right is even. You right is odd. We both see who can get more hits on their package.
Want those NPM numbers?
Yeah.
At
Also,
the
I'm
end
gonna.
of the day,
Yeah. And
I'll just bot it. Just bot download.
what's
everything.
this CLI? It's open code. Hashtag ad. If you want to use open code.
Dax,
install
I'm
it.
sending you a bill. See you guys later.
Dax,
Bye-bye.
you owe us a lot of money for this. Bye.
Okay, that's the end of the episode. Thanks.
Thanks, everyone.
Thanks,
Yeah,
Ed.
I hope
I mean,
that went as expected. I hope that was smooth enough.
it was
No, that was
awesome.
fun.
That's great.
That
That's
It was
great, yeah.
awesome, Ed. It was
Cool, cool, cool.
awesome.
We know more.
Great.
good.
Everybody
Yeah.
knows more.
And then in
Now-
the next one,
I'm pretty sure Teej already knew everything.
I
but
did
it's
not.
fine.
I did not know
Oh,
everything.
God.
yeah,
This guy was
the,
one-shotting the debugger in like 30 seconds.
Yeah, the minute I saw TG was like break, start, lay next, blah blah blah, blah step by, I was like,
That was just memorizing what he just said before. He said,
Yeah,
hey,
yeah, whatever.
do the thing. I had to click enter 3 times. So, okay, clicked enter 3 times. What do you guys want?
Teach practices all night and tries to pretend like you can.
You're not fooling anybody.
What are you gonna do now,
Um,
Teach?
all right, I gotta go. Wife needs me.
Later,
See you
bye.
later. Bye.
Are you uploading?
Vegan, are we still doing the
Yes.
mastermind thing in a minute, or can we move that to
Yeah,
tomorrow?
let's do it. We can do it tomorrow, or we can do it in a minute. I'm down for
Can we do
it.
it in
We're
30
still
minutes?
live.
Let's do it in
so
30 minutes.
just
Okay. All right. Bye, everybody.
Bye.
Everyone's watching your conversation.
Don't know what
okay.
you guys are saying, so just
That's
be
okay.
careful.
We
Okay.
have a Magic the Gathering mastermind. We think we can pieneer some new deck building techniques. And
Oh,
so
okay,
we
gotcha.
think. I mean, like
Gotcha.
Magic is Turing complete. So
Bye, everybody. My friends made fun of me because I'm smart. Yeah, true.
idiot.
Nerd.
Idiots. Nerd.